So this is the video solution to the sheet on simultaneous equations. So first thing to realize is we have a column of x's, column of y's, and column of numbers. So we will be looking to use elimination to do this. We see that the y terms look almost the same, they're both 2y. Only thing is they have opposite signs. And as we discussed in class, we often think of that as meaning that they point in different directions, and so when you add them up, they'll just cancel each other out. So to eliminate those two terms, we are going to add the two equations. So for the x's, we have 4x plus x gives us 5x, and the y's will cancel, and we'll have 8 plus 2 gives us 10. Which means that x will equal 2. We're not done yet. We have to take this answer x equals 2 and we're going to substitute this back into one of our original equations. Now I'm going to choose to use this bottom one here because it just seems a bit easier. And the only thing that's going to happen with this equation is that the x here is going to become 2 because we now know that x equals 2. So we rewrite that where x is changed into 2. And we get 2 plus 2y equals 2. A lot of 2's there. But what we can do is subtract the 2 from both sides. We can cancel them off. Okay, and so the right we have nothing left. And so we really have 2y equals 0, which means that y must equal 0 as well. Okay, next one. This is a bit different. We've lost the structure of column of x's, column of y's, and column of numbers. But what we do have is one equation just straight up says x equals something. Okay, and if you just see x equals something or y equals something, easiest way to do these is to just take that and substitute it into that x there. Okay, so we rewrite the top equation where that pink x has now turned into the negative 3 plus 5y that we can see from the bottom equation. Okay, so we've substituted the negative 3 plus 5y into that x. Okay, so this is actually a lot easier to solve because we only have y's, we don't have x's anymore. Okay, and so we can just expand these brackets, and so what's going to happen is 3 times negative 3 is negative 9, and 3 times 5y is 15y. We now group the y's together on the left side, so 15y plus y is just 16y. And now we have to try and get the y by itself. So we see a negative 9 up the front. We can undo a minus 9 by going plus 9 on both sides. And so we get 16y by itself equals 16, so y equals 1. So once more we take this first answer and we want to substitute this back into an original equation. Okay, and we want to find x, right? So the bottom equation is going to be a lot more helpful because it just tells us what x equals. Okay, so we take y equals 1, we put it into this y here, and what we're going to get is that x equals negative 3 plus 5y, but y is 1, so it'll be 5 times 1. Okay, and so that means it's negative 3 plus 5, which is 2. So we have x and y now, we're finished. Alright, so this one here, same sort of deal. Okay, we see there's an x equals on the bottom. Okay, which means the easiest way is to once again substitute that into that x there. Okay, so we replace that x now with 2y plus 2. And that's what we end up with. 2y minus 5y, we group those first. So 2y minus 5y will become negative 3y, and the plus 2 stays. Okay, so nothing happens to the plus 2, so it will just stay the same on the left-hand side. But we can get rid of the plus 2 by going minus 2. So we do that to both sides, and we get negative 3y equals negative 12, which means that y must equal 4. 3 4s are 12. So we take this y equals 4, and we put it back in once more into that x equation there. Okay, and we want to now say that this y is equal to 4. So what we're going to write then is that x equals 2y, so 2 times 4 plus 2, and that gives us 10. Okay, next one. So, this one's back to having a column of x's, column of y's, and a column of numbers, and so we will look to use elimination. Okay, but the harder thing with this one is that we don't have the x terms being the same or the y terms being the same. But what we can see though is the y terms are pretty close. All I have to do to make them the same is I double this top equation. So I multiply everything by 2. So 2x becomes 4x, y becomes 2y, and 4 becomes 8. And why this is helpful is because if we take the bottom equation and sort of move it over here as well, we see now that the 2y and 2y are now the same. Okay, but they have opposite signs, one's positive, one's negative, and so again, to get rid of them, we have to add these two equations together. Alright, so 4x and 3x, we add them, we get 7x. The y's cancel, 8 and 13, add them, we get 21. And of course, 7 times 3 is 21, so that means x equals 3. So we take this one and we once again substitute into one of the equations, any of them that we can see. Now the easiest one I think would be this one right here, where we have x now equal to 3. So we do that, we write 2x, which means 2 times 3, plus y is equal to 4. But 2 times 3 is just 6, so we can write that. And so the last thing we do is to get rid of the 6, we have to minus it from both sides. And so 4 minus 6 gives us y equals negative 2. Okay, this one is once more an elimination one, x's, y's, numbers. But this time it's sort of even worse because we can't really turn 2x into 3x that easily. We can't turn 4y into 5y that easily. But if we just focus on the x terms for a bit, what we can do is turn both 3x and 2x into 6x. Okay, the aim is to make them the same, and 3 and 2 can both become 6. So how does 3x become 6? I have to multiply by 2. And so I multiply everything in the equation by 2. So 3x becomes 6x, negative 4y becomes negative 8y, and negative 1 becomes negative 2. And so look at the bottom equation now. How do I turn the 2x into 6x as well? Alright, I have to multiply by 3 this time. So I do that. So 2x becomes 6x, 5y becomes 15y, and 30 becomes 90. Okay, and so now we have 6x and 6x, they're the same now, so we can use elimination to make them go away. Okay, so we label the equations 1 and 2 to make things a bit simpler this time, and we subtract them because the 6x's have the same sign, they're both positive. Okay, I'm going to subtract 2 minus 1, makes the negatives a bit nicer, because we'll see that 15y minus negative 8y, so minus 8y, really just means 15y plus 8y, so we get 23y, and on the right it's the same thing, 90 minus 2 gives you 90 plus 2, so 92. So 23 times what's 92, we can divide and we'll see that y must equal 4. Okay, 23 times 4 is 92. So we take this answer and we put it back into one of our equations. I'm going to choose to use this one. Okay, so we rewrite this equation where the y now equals 4. So it's 2x plus 5y, so 5 times 4 equals 30. 5 times 4 is 20, so we can just write that. And we can get rid of this 20 by subtracting from both sides. So we get 2x by itself equals 10, and so x equals 5. 2 5s are 10. Okay, so this one, back to substitution I think, because the first equation says y equals, so that's a substitution right there. So you look at the second equation and you take your y, which I've put in pink, and you replace it with the 2x minus 3 from the top equation. We take the brackets and we expand, just be really careful with the negatives, so negative 3 times 2x is negative 6x, but negative 3 times negative 3 is positive 9. Okay, we look at the left side. We can group the x's together. So 8x minus 6x is 2x. Then we can get rid of the plus 9 by going minus 9 from both sides, which gives us 2x by itself equals 14. Then we can just divide by 2 to see that x must be 7. Okay, so 2 7s are 14. Alright, we take this x equals 7 and we substitute this back into the y equation, okay, to find the y. So we know that this x must be 7, so we can write once more y equals 2x, so 2 times 7 minus 3, and so y would be, what, 14 minus 3, that's 11. Okay, so that's all the pure simultaneous equations, right? And so these next ones may use a few of these ideas. You might not see it come out as much, but the ideas are still there. So, rectangular fence is built with 40 meters of fencing. Length is 4 meters longer than the width. Want the dimensions of this fence. So we better draw us a fellow rectangle first. I might label the width to be W, and because the length is 4 meters longer, I can write that now as W plus 4, so 4 meters longer than the width. Okay, what we're also told is that it's built with 40 meters of fencing, so I want to trace my way around this fence. This side is W plus 4, this side is W, this side is W plus 4 again, and this side is W again. And in total, this is 40 meters of fencing, so all of that must equal 40. Alright, so we're just going to tidy up the left-hand side. I count 4 W's there, and it's plus 8 in total, so it'd be that. We take out the 8 by going minus 8 from both sides, which gives us 4W equals 32, and 4 times 8 is 32. Alright, we want the dimensions of the fence. 8 is the width. The length, we're told, is the width plus 4, so that means the length must be 12. Okay, I really should have put meters there, but you know. Alright, next one. Okay, so you paid $10 for a drink and a kebab. Alright, might take this. I'll call a drink D and a kebab K, and so this tells us that D plus K is 10. Okay, next bit of information says that your friend, who also had to buy food for friends, blah blah blah, paid $35 for 2 drinks and 4 kebabs. So for 2 drinks and 4 kebabs, that is $35. So written in our language, it means that 2D plus 4K is 35. Okay, so we want to see how much each item costs separately, which means we want to solve these equations to find D and to find K. Okay, so this looks awfully like an elimination problem, so we're going to try and make the D's match up. Okay, you can do it either way you want, but I'm going to choose to multiply the top by 2. Okay, so that gives us 2D and 2K, and the 10 becomes 20. Why this is helpful is because if we move the bottom equation across, we can see that the 2Ds are the same. And so labeling the 2 equations again, we can eliminate them by going bottom equation minus top equation. Okay, so the D's will go away. 4K minus 2K is 2K, 35 minus 20 is 15. And so if 2 kebabs cost $15, 1 kebab would cost $7.50. Okay. We want to know how much a drink costs as well, but if you go back to the first sentence, we know that a drink and a kebab cost $10 in total, so that means the drink has to cost $2.50 to make up $10 in total. Okay, next one. Fruit store, banana costs 30 cents more than an apple, so 4 apples and 3 bananas cost $4.40. How much does each type of fruit cost? Okay, so banana costs 30 cents more than an apple. Let's call a banana B and apple A. That would tell us that B equals A plus 30, so 30 more than A. Next, we're told that 4 apples and 3 bananas cost 440, and so we can write that as 4 apples, 4A, plus 3 bananas, 3B, would be 440 in total. Now, we're working in cents here, so I'm going to write 440 rather than $4.40. Okay. And this time it looks quite like a substitution one. We're given B equals something, so we can substitute that into the B in the bottom equation, okay, where I've put it in pink. So we can rewrite that bottom equation, but we replace the B with A plus 30. And so like before, this gives us some brackets to expand, and so we should do that. 3A is just 3A, 3 30s are 90. Then 4A plus 3A give us 7A. And we can get rid of the 90 by going minus 90 to both sides. This gives us 7A equals 350. That's 440 minus 90. And if you divide by 7, you'll get that A equals 50 cents. So every apple costs 50 cents. Okay. And so once again we take this answer there, we substitute that back into our B equation. And so that means that a banana must be 50 plus 30, so 80 cents. Okay, I think this might be the last one. So we have 70 coins in our wallet. I only have 5 cent and 10 cent coins. They total to 385. I want to find how many of each type. Okay, so we're first told we only have 5 cent and 10 cent coins, but we have 70 in total. I'm going to say we have F number of 5 cents and T number of 10 cents, and so they must add to 70 because we have 70 coins. Okay, but the value of them total to 385, and so once again working in cents, that tells us that 5F plus 10T equals 385. Okay, 385. Before we go on, I might simplify this bottom equation by dividing everything by 5. Okay, if you sort of look at it, you can tell that everything is a multiple of 5, so you can make things a lot easier for yourself if you divide by 5. Okay, so dividing by 5, what we see is that the 5F, the 5 will go away. For 10T, it will become 2T, and 385 divided by 5 is 77. Okay, so now this looks a lot simpler. We have a bunch of F's, bunch of T's, bunch of numbers, and so we're going to use elimination to do this one. The F's are already the same, and so it's quite an easy one to eliminate. We just go bottom equation minus top equation, and the F's disappear. 2T minus T is just T, and 77 minus 70 is just 7. And so we actually get one of the answers straight away from this. Okay, so T equals 7. We have 7 10-cent coins. But if we have 70 coins in total, and 7 of them are 10-cent coins, that means we must have 63 5-cent coins to make up the 70. Okay, and so I think that's it. Do rewind and rewatch if you need to. And yeah, make sure you understand all of this. I might not spend too much more time in class doing this. And so yeah, do go through this a lot. Ask me if you have any questions, either at school or email or anything like that. Okay, thanks for watching, and I'll see you later. Bye.